All right, so 4-7 is the inverse trig function. So the basic concept here, the overall concept of inverse trig functions is that you are going to be given the trig function's answer and you have to tell me the angle where that comes from, okay? There's two parts to it, like part is from unit circle, part is from a triangle, but that's basically the entire idea behind it. There's a lot of like why at the beginning of this, so I'm going to try to go through this without boring you too much, but also get to the point. The inverse sine function is defined by y equals arc sine of x if and only if the sine of y equals x. So you're going to say this two ways. You're going to see it written as arc sine and you're going to see it as sine negative 1 of x. And those are exactly the same things. They are interchangeable. They mean the same things. And what they mean is if this is the answer to the sine of an angle, what angle does it match? So if I gave you that the sine of something was 1/2, you would go to your unit circle and you would find all the places sine, which is your y, is 1/2, and you would give those answers. So if I just did it from the natural unit circle, you'd give me all those angles in which your y is 1/2, or your y is √3/2, or your y is √2/2, or your y is 0, or your y is 1, or your y is -1. All of those things come from your unit circle. Now the catch here is for something to have an inverse, and this goes back to chapter 1, but in order for something to have an inverse, it has to pass your horizontal line test. It has to be 1-to-1. And if I do my full curve, it won't pass your horizontal line test. If I were to just look at the sine curve here on the right, this would fail your horizontal line test, which means it doesn't have an inverse. So what we do is restrict it. We restrict it to just one part of that curve. And that restriction is from -pi/2 to pi/2 to +pi/2. And then that would pass your horizontal line test and that would have an inverse. So when it asks you for the sine or the angle that has a sine of a specific value, we're looking at only part of our unit circle. So I'm going to pull in the unit circle just so that we can like visualize it. But if I was to restrict this from -pi/2 to +pi/2, where is -pi/2 on my unit circle? It's at the bottom at 270, right? This is the same thing as -pi/2. And then where's +pi/2? All the way up here at 90. So we're saying only use this part of our unit circle when we're answering these questions. Yep. So I'm actually a good question, and I'm glad that you said it because I forgot to tell you, but I'm going to give you a little blank one on Wednesday, the day before your test, and you can fill in as much or as little of it as you can, as you want to, from your brain. So like we're going to put everything away. I'm going to give you a couple minutes. You could do the whole unit circle if you want to. You could just do part of it because it kind of like duplicates as you go around. It's completely up to you how much you put on it, but whatever you put on it, I will then give you back on Thursday for your test. Yeah.
Can I put like other random stuff there?
You can put up to the tangents, and that's where I'm going to cross the line. Or the acronym, like all students take calculus, but then that's it.
So I can't put like stuff that has nothing to do with the unit circle?
If you put stuff that doesn't have anything to do with the unit circle, I'm putting it right in the garbage can. So don't waste your time. Yeah. I'm not going to check them for correctness, so like be really careful. But I will check for like added stuff. So if it's incorrect, you get it back. You can obviously change it. Like if you go home and you're like, oh my gosh, did I switch the over 3s and the over 6s? Go home, check it. You can come back. You can change whatever you want on it. But I'm not going to grade them. So just be really careful. All right. So I would actually say you could even add that on your unit circle when you fill it out. You could write sine like that. So you know. You could add the negative angles. Anything that's unit circle related, you could do. Okay. So if I were to say which of these angles has a sine equal to 1/2, what's your answer? Pi/6. And only pi/6. I would not include anything on this side, which the other one would be 5pi/6, because it is restricted. If I said which of these has a sine of -1/2, you would tell me what? So 11pi/6 has the equivalent form of negative what? No, the angle. -pi/6. And that's what you have to use. negative pi over 6. So this one would be positive pi over 6, and the other would be negative. Again, we're restricting that domain, so it's important for sine that you only use the right side, and specifically in the fourth quadrant, you would change it to the negative angles of that quadrant. Which means, honestly, these are the only questions you can be asked. That bottom box are the only questions I can ask unit circle based. Sine of negative 1, or sine negative 1, sorry, of negative 1, negative root 3 over 2, negative root 2 over 2, negative 1/2, 0, 1/2, root 2 over 2, root 3 over 2, and 1. So you could memorize this chart if you wanted to, but you also have to do it for cosine, you'll have to do it for tangent. So it's easier to just know what you're looking for, okay? But it will be one of those if it's sine. All right, so given what we just talked about, if you wanted to, again, pull in your unit circle, I would say we would tweak it so that we know it's just the right side. And I would go as far as adding on your negative angles. Negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. So the setup on that might take a little while if you want to fill it all in on Wednesday, but then having it already done is going to make the rest a lot easier. Because A says find the exact value of sine negative 1 of 0. What's the answer there? Give me from negative pi over 2 to pi over 2. Zero. What's the exact value of arc sine of negative 1? Negative pi over 2. What's the exact value of sine negative 1 of negative root 3 over 2? Negative pi over 3. Remember, give the negative version of that because we are restricted from negative pi over 2 to positive pi over 2. Arc sine is the same thing as sine negative 1. So these are used interchangeably. It's the same thing. Yep.
So sine's always the right side?
Sine is the right side, and tangent's going to be that too. Yep. And notice we're giving all these answers in radians. You will do the same. You will give them in radians.
How did you find the last one?
So if you look at your unit circle, if I go to just the right side and I find where the y is negative root 3 over 2, it's here. And that angle is negative pi over 3. Yep.
Why did it be sine negative 1? Like with the pi to negative 1, like sine of pi to negative 1. Or is it going to be like regular sine?
So if it asks for the sine of something, it has to be the sine of the angle. So sine of pi over 3 is that kind of question. Or if it's asking for the trig function, like if it gives you the trig function, it has to be sine negative 1 or arc sine. Yep. All right, now we're talking cosine. So the difference between cosine and sine is our general shape of cosine. Oops. Looks like this. So we can actually restrict this one. This would be pi. We can actually restrict this one from 0 to pi, and it would pass our horizontal line test, which means it has an inverse. So for cosine, we use the top of your unit circle. We go from 0 to pi. So if I was, again, to look at my unit circle, we use the top for cosine. We don't change any angles. We use the natural angles there from 0 to pi. And for cosine, you're looking at the x-coordinate. So if I said, tell me the theta if the cosine is root 3 over 2, you'd tell me it's pi over 6. If I told you, tell me the theta where cosine is negative root 3 over 2, you would tell me it's 5 pi over 6. Which means that I only have these to choose from. I can only give you cosine negative 1 or arc cosine of 1, root 3 over 2, root 2 over 2, 1/2, 0, negative 1/2, negative root 2 over 2, negative root 3 over 2, and negative 1/2. Okay, there's a limited bank of questions that you can get asked. Unit circle based. So let's pull in the same. I'm gonna keep pulling in so that we can keep talking about what would be altered. If I had it like this would be my sine. I would do the negative angles. Why did I just do that? That's pi over 4. Negative pi over 3. Negative pi over 2. And for cosine, I'm going to use the top part. So what is arc cosine of 1? 0. 0 is where cosine is 1. What is cosine negative 1 of root 2 over 2? Pi over 4. What is cosine negative 1 of root 3 over 2? Pi over 6. Again, giving these answers in radians. Questions so far? All right, last up is tangent. And tangent, we restrict the same as sine, except we can't do pi over 2 and negative pi over 2 because what happens to tangent at negative pi over 2 and positive pi over 2? It's undefined. So the only difference is that instead of it being in brackets or including those points, it would literally just be from negative pi over 2 to positive pi over 2. Okay, so that means that tangent is restricted to just these questions, right? So I can only ask you where tan negative 1 would be. Undefined, negative root 3, negative 1, negative root 3 over 3, 0, root 3 over 3, 1, root 3, or undefined. Again, you're limiting that bank. Here's all three on one side. So we said it, but we'll say it again. Sine is restricted from negative pi over 2 to positive pi over 2, including those two angles. Cosine goes from 0 to pi. And tangent goes from negative pi over 2 to positive pi over 2, not including those angles because it's where it's undefined. So if I were to use, and this is what like if I was taking your test on Thursday, then on Wednesday I would make sure I could fill in whatever you see there. I would add on it the tangents here. And I would add on the tangent values. So 0, root 3 over 3, 1, root 3, undefined. Negative root 3 over 3. It's really hard to read. Negative 1, negative root 3, and undefined. Now it's like you have your cheat sheet. Like everything that you need to answer these types of questions are literally on that unit circle. So tan negative 1 of root 3 over 3 is what? Negative pi. Oh no, positive pi over 6. Yeah, you're right. Sorry. Arc tan of negative 1. Negative pi over 4. And tan negative 1 of negative root 3. Negative pi over 3. Good. Questions? So all of that is like without your calculator, okay? And then there's one other small part with the right triangles, but then there's other going to be times in which you are going to have your calculator. So all of these are inverses, which means we're using the negative 1 buttons, okay? It's either sine negative 1, cosine negative 1, tangent negative 1. That's one super important thing. The other super important thing is this mode is in radians. We answered every single question of these in radians. You have to be in radians. So think I'm going to have to switch back and forth. Pay attention to when you're in degrees. Pay attention when you're in radians, okay? These questions will look like this. Use a calculator to find the value and round to 4 decimal places for each function. So I'm going to make sure my mode is in radians. And when we reset calculators at the beginning, you'll be in radians. And then I'm going to do second tan to get tan negative 1, negative 5.2. And I get negative 1.3808. I'm going to do second cosine 0.2. And I get positive 1.3694. And I'm going to do second sine 0.8. And I get 0.9273. Questions? What would happen if I asked you to do arc sine of 5.2? Try it in your calculator. What happens? What's it say? Error, domain. Why is it saying that? Can sine go past 1? No. Remember, think about your like amplitudes, right? It can't go higher than 1. So sine and cosine can't be bigger than 1, it can't be less than -1. It's not possible.
So how do you do C?
How do you do C?
Yeah.
Second sine is the same. Arc sine is the same thing as sine -1. These should be like easy, gimme questions. Be careful on your rounding. Be careful, make sure you're in the right mode, right? It would suck to lose all the points because you're in the wrong mode. Don't do that.
What about cosine? Is it also 1 and negative?
Cosine and sine are both the same, -1 to 1.
And then tangent would be-
Tangent is unlimited.
Oh,
Yep,
okay.
because tangent, so like if you think about it, so like if it's sine, you're saying that the hypotenuse is smaller than the opposite side, which is impossible.
Yeah.
Yeah, same for cosine, you're saying the adjacent side is bigger than the hypotenuse, which is impossible.
Yeah.
Yeah.
Okay.
All right, this one says use an inverse trig function to write theta as a function of x. So now we're back to our right triangle trig. You want to locate theta, it's in the corner here. And then where is x plus 2 in respect to theta? Good, and 6 is hypotenuse. Which trig function would you use? Sine. So I would say the sine of theta equals the opposite side, which is x plus 2, over the hypotenuse, which is 6. And that's what it means. Write theta, well, almost. Write theta as a function of x. So if I wanted to solve for theta, I would say theta equals sine -1 of x plus 2 over 6. So I rewrote theta in terms of x.
Could you plug that into the calculator?
No, you have 2 unknowns. You'd need at least one more.
Oh, okay.
If I knew what x was, I could find theta, or if I knew what theta was, I could find x, but I can't. I have 2 unknowns there. All right, now we're going to talk about composition of functions. So you are going to see 2 things happen. A combination of your inverse functions and your regular functions. So if it said sine of sine -1 of x, I'm going to work myself inner ways out. So if it said sine -1 of x, I'm looking for the angle in which that is my x value. Well, for sine, it would be the y value. And then it wants you to find the sine of that same angle. Sometimes these are going to have the same answers if it's the same, but sometimes they will have different answers depending on what you're asking for, and sometimes you're going to have a different combination of trig functions. So it might say find sine of cosine -1 of something. So you're going to go innermost parentheses first, you're going to figure out which angle has that cosine, and then you're going to find the sine of that same angle. So you'll see these 2 ways, trig functions from your unit circle, and then also ratio of sides where you'll have to set up a right triangle. So go to A first. This says find sine of sine -1 of 5 pi over 6. So I'm starting innermost parentheses first. So if I just had this question, if it just said find, wait, this should say sine. Get rid of that -1. That should say sine. You can't find sine -1 of an angle. This should be the reverse, like that. Sorry. So if it said, start with the innermost first, sine of 5 pi over 6. What is sine at 5 pi over 6? I would go to my unit circle, yes. I would go to 5 pi over 6. And I would look at the sine value, which is the y, right? Which is 1/2. Then it says sine -1 of 1/2. Why would it not be the same angle? Why would it not just be 5 pi over 6?
It's pi over 6.
It's pi over 6, and why?
It's the -1, so it has to be on the other side.
Good. It's because we restrict the domain on this. We say we can't use quadrant 2 for sine. We say we use quadrant 1 and the negative version of quadrant 4, which means I would only grab from where this is my y, and my answer there is pi over 6.
So you wouldn't need a calculator to do that?
You don't, right? None of these will have a calculator, because even something like we're going to do C before we do B, but we'll go back to B. Even B, you set up a right triangle. All right, go to C. Now it says tangent of 2 root 3 over 3. Actually, well, is there an answer in our unit circle that is 2 root 3 over 3? No. So I should have done B or C. It doesn't matter. But that means I can't pull from my unit circle. Okay? I'll we'll go through it first, and then I'll tell you what you could have done. But what I can do is set up a right triangle. So I'm going to set up a right triangle. I'm going to put theta in the corner. Doesn't matter where you put it. And then tangent is what, two sides? Opposite, 2 root 3, adjacent, 3. Before I even find that third side, I would look to see if I need it. If it wants me to find cosine of that same angle, I need the adjacent and the hypotenuse. So now I know I do need it. How do I find that missing side? Pythagorean theorem, 3 squared plus 2 root 3 squared equals my radius squared or my x squared, whatever variable you want to call it. 9 plus 4 times 3, 9 plus 12, 21. So x would equal the square root of 21. And then my cosine would be 3 over square root 21. And we rationalize. And I get 3 root 21 over 21. And we simplify. Square root 21 over 7. So if they are not unit circle angles, you set up a right triangle, or unit circle values. Now the only other thing I would have said is if this could have been a unit circle value that was rationalized, so you could flip it to check it, but honestly I would just set up your triangle. So now go to B. So cosine negative 5 over 13. So again, those are not unit circle values. I put theta in the corner. Cosine is 5 over 13, which is adjacent over hypotenuse. Sine, I need the opposite for. So what's the opposite side? 12. Remember the triple is 5, 12, 13 is one of them. And sine is opposite over hypotenuse, or 12 over 13.
For the answer, do you have to write sine?
Nope, it's just 12 over 13.
Okay.
Yep. So if it's unit circle based, then obviously you use your unit circle. If it's not, then you're setting up a right triangle. Questions? We made it. We are done with chapter 4. There's another section. We are not doing it. It's application of the sine curves and all that stuff. So we are done.